Dear children, you are welcome to this channel. We have come to the concluding part of the third chapter, Theory of Equations. That is, in this video, we are going to see the last exercise 3.7, which is objective questions. Exercise 3.7, a 0, the first question is a 0 of x cube plus 64 is dash, and the options are 1, 0, second option is 4, and the third option is 4i, and the fourth option is minus 4. Okay. So, what do you mean by 0? The value of x which makes this polynomial 0. Okay, that is called 0 of this polynomial, right? So, in order to find the 0 of the polynomial, what you have to do? You have to equate the given polynomial to 0 and find the value of x, right? So, equating x cube plus 64 equal to 0 gives, we can factorize this using the formula a cube plus b cube, as 64 is 4 cube. So, this is nothing but x cube plus 4 cube equal to 0. So, using the identity a cube plus b cube in the factorization form, it is nothing but x plus 4 into x squared minus 4x plus 16 is equal to 0. So, this implies either x plus 4 equal to 0 or x squared minus 4x plus 16 equal to 0. This implies x is equal to minus 4 or this quadratic x squared minus 4x plus 16 equal to 0. See, if we equate this, this will give two imaginary values for x, and this x is equal to minus 4 is one real value. But among the options, we have minus 4 as the fourth option. So, let us take this. What is the answer for the 0 of x cube plus 64? Minus 4. This minus 4, this 0 is given here. So, we no need to find out this value of x here. So, let us choose this. So, what is the answer for this question? Option number 4. The answer is minus 4. Second question is, if f and g are polynomials of degree m and n respectively, and if h of x is equal to f composite g of x, then the degree of h is dash. Options are, first option is mn, second option is m plus n, third option is m power n, and fourth option is n power m. Okay. So, given that f is a polynomial of degree m, so let us take f of x to be some x power m simply, okay, as it is a polynomial of degree m. And similarly, g of x is a degree of polynomial of degree n. So, let us take g of x to be some x power n simply, right. Then h of x is equal to f composite g of x, that is nothing but f of g of x, that is f of x power n. Now, what is f of x power n? X power n, the whole to the power m, that is according to the exponential rule, the power will be multiplied. So, it is x power mn. So, what is it is also a polynomial of degree mn. So, h of x, that is f composite g of x, is also a polynomial of degree mn. I have taken only the leading coefficient, other coefficients are taken to be 0, right. Therefore, what is the degree of h of x? Mn, and this is given in option number 1. So, the answer for the second question is option number 1, mn. Then third one, a polynomial equation in x of degree n always has dash. Option number 1, n distinct roots. Option number 2, n real roots. Option number 3, n imaginary roots. And 4, option number 4 is at most one root. See, you know that if a polynomial equation is of degree n, and it will always has n roots, okay. So, but not all the n roots will be distinct. There may be some equal root. Therefore, option 1 is not a correct answer, okay. This is not the first one is not the correct answer for this, because the option 1 is given as n distinct roots. But you know that all the roots may not be distinct. There may be some equal roots. So, this option fails, okay. Now, and come to the fourth option, it is given as at most one root, but it is of degree n, means it should have n roots. Here it is given that maximum it will have one root, that is also not true. So, this is also a false statement, right. Now, What about the second and third option? Means second option says that it has n, always has n real roots, and always has n real root means this is also not true. There may be some imaginary roots, so this also fails. So it therefore what is therefore the remaining option? Option number 3, n imaginary roots. So a polynomial equation in x of degree n always has n imaginary roots, but you may have a doubt that there may be some real roots. Why you are saying that all the n roots are imaginary roots? Okay, so let me explain that. That is, n roots, among the n roots there may be real and there may be imaginary. Okay, some imaginary roots will be there, or all the roots may be real, or all the roots may be imaginary, but all the real roots can be expressed as, okay, as imaginary roots by taking the imaginary part as 0. So all real roots can also be taken as imaginary roots by considering the imaginary part as 0. So if you take all the real roots existing for a polynomial equation as the imaginary roots by taking the imaginary part as 0, then the remaining the imaginary roots together with this real roots can be says that n imaginary root. Okay, so a polynomial equation in x of degree n always has n imaginary roots. So this is option number 3. So n imaginary roots. Okay. Then fourth one, if alpha, beta and gamma are the zeros of x cube plus p x squared plus qx plus r, then sigma 1 by alpha is dash. And the options are option number 1 minus q by r, option number 2 minus p by r, option number 3 q by r, and option number 4 minus q by p. Okay. So given the polynomial, and alpha, beta and gamma are the zeros. So by Vieta's formula, you know that alpha plus beta plus gamma is equal to minus p, and alpha beta plus beta gamma plus gamma alpha is equal to q, and alpha beta gamma is equal to r by Vieta's formula. Okay, then sigma 1 by alpha is nothing but 1 by alpha plus 1 by beta plus 1 by gamma. Then by taking LCM alpha beta gamma, the numerator will become beta gamma plus alpha gamma plus alpha beta. Then just substitute the values, that is q divided by, so this is minus r, alternative minus plus, so it will be alpha beta gamma is minus r. So q divided by minus r, that is equal to minus q by r. So what is that first option? So the answer for the fourth one is option number 1 minus q by r. Fifth question is, according to the rational root theorem, which number is not possible rational 0 of the polynomial 4x power 7 plus 2x power 4 minus 10x cube minus 5? The options are minus 1, 5 by 4, 4 by 5 and 5. Okay. So according to the rational root theorem, if any rational 0 exists for a polynomial that is of the form, rational 0 means it is of the form p by q, then this p and q should satisfy some condition. What is that condition? P should satisfy, that means p must be a factor of the constant term minus 5, and q must be a factor of the leading coefficient 4. Okay. So let us denote this leading coefficient as an and this one as a naught. So p must divide this a naught and q must divide an. So and then we have to find out the possible values of p by q from this, right? This is the rational root theorem. This is the one which gives rational root theorem says, right? So according to the rational root theorem, p should divide a naught. That means what would be the possible values of p? Plus or minus 1 and plus or minus 5, right? And similarly, the possible values of q which divides this a and 4 is plus or minus 1, plus or minus 2 and plus or minus 4. So what would be the possible values of p by q using this p and q means plus or minus 1 and plus or minus 1 by 2 and then plus or minus 1 by 4, then plus or minus 5, plus or minus 5 by 2 and plus or minus 5 by 4. So, among these values some some rational value exists, rational 0 exists for the given polynomial. But here the question is which one is not a possible rational 0, right? Here the first option is minus 1. So, minus 1 is one of the value of p by q, and 5 by 4 is also one of the values of p by q, and then 4 by 5. Here 4 by 5 does not exist. Therefore, this is not a possible rational 0. Okay. And moreover, look at the fourth option 5, it is one of the values of p by q. So, the correct answer, that is the not possible rational 0 is 4 by 5. So, the answer for this question is option number 3, 4 by 5. The question number 6, the polynomial x cube minus k x squared plus 9x has 3 real zeros if and only if k satisfies. And the options are modulus of k less than or equal to 6, k equal to 0, modulus of k greater than 6, and modulus of k greater than or equal to 6. So, to find out the zeros of the polynomial, let us equate it to 0. Okay. So, x cube minus k x squared plus 9x is equal to 0 implies. So, you can factorize this as there is no constant, that is by taking x common outside, it will be x squared minus kx plus 9 equal to 0. That is, this implies that either x is equal to 0 or x squared minus kx plus 9 equal to 0. So, x is equal to 0 means that is a real value, real 0. Okay. So, one real 0 is 0. One real 0 of the polynomial, that is one real root of the polynomial is 0. Then this quadratic gives 2 real zeros. Okay. Because the question has given that this polynomial has 3 real zeros. So, this quadratic should give 2 real zeros. Okay. So, that means that when a quadratic will have real values, real root means the condition is the discriminant must be greater than or equal to 0. So, x squared minus kx plus 9 equal to 0 to get real zeros from this is implies the discriminant value, that is k squared minus 4ac, 4 into 1 into 9, that is 36, must be greater than or equal to 0. This is the condition, that is k squared is greater than or equal to 36 or modulus of k is greater than or equal to 6. Okay. So, what is the condition for this quadratic to give real zeros? Then only we have the given polynomial has 3 real zeros. That means that modulus of k is greater than or equal to 6, which is nothing but option number 4. So, option number 4, modulus of k greater than or equal to 6 is the correct answer. Then 7th one, the number of real numbers in the closed interval 0, 2 pi satisfying the equation sin power 4x minus 2 sin squared x plus 1 is equal to 0 is dash, and the options are 2, 4, 1 and infinity. See, this comes under non-polynomial equation. So, in such cases what you have to do? You have to reduce this to a polynomial equation in some other variable. So, let us replace sin squared x by t. Therefore, this implies sin power 4x will become t squared. So, if you take sin squared x as t, then the given equation reduces to t squared minus 2t plus 1 is equal to 0, and this is nothing but t minus 1 the whole square. So, t is equal to 1 twice. Okay, t is equal to 1. That means that sin squared x is equal to 1 or sin x is equal to plus or minus 1. So, within this interval, one complete revolution 0 to 2 pi, that is within this interval 0 to 2 pi, for what values of x it will be, sin x will be plus or minus 1 means sin x will be equal to 1 when x is pi by 2, and sin x is equal to minus 1 in this interval means x will be 3 pi by 2, that is at 90 and 270 it will take the value plus 1 and minus 1. So, only 2 values. Okay. So, the number of real numbers in this closed interval 0 to 2 pi which satisfies the equation is only 2. So, which is nothing but option number 1. Then question number 8. If x cube plus 12x squared plus 10ax plus 1999 definitely has a positive 0 if and only if dash. The options are a greater than or equal to 0, a greater than 0, a is less than 0 and a less than or equal to 0. See, look at the polynomial. The given, except this term a is unknown, so leave this. All the other three has positive sign. It is fixed. Okay. So according to the sign of a, we can get the sign changes. If a is positive, there won't be any sign change. That means that this polynomial will not have a positive 0. But the question is, it has definitely at least a positive 0, at least one. That is, definitely has a positive 0. That means that a should not have the sign plus. That is, a greater than or equal to 0 or a greater than 0 doesn't suit this. Okay. So only if a is negative, right? If a is at least, when a is equal to 0, then this term will not present. Again, the three terms will have the same positive sign. Therefore, this also does not suits this. This condition also not holds good. Okay. So only this a is less than 0, that is, if a takes a negative sign, then only we have two sign changes. So if a is negative, so what happen if a is negative, x cube plus 12x square, this will become minus. Okay. When if a is negative, then 1999 means there will be two sign changes and hence there will be at least the maximum number of positive zeros will be 2. So then only it satisfies the condition that it has definitely as a positive 0. So a should be less than 0, that is, a should be negative to get this condition. So what is the answer for this question? Option number 3, a is less than 0. Ninth one, the polynomial x cube plus 2x plus 3 has dash. Options are 1 negative and 2 imaginary zeros, 1 positive and 2 imaginary zeros, 3 real zeros and no zeros. Okay. So to find out how many real zeros and how many imaginary zeros, let us apply the Descartes rule. So let us take the given polynomial to be p of x, that is x cube plus 2x plus 3. Is there any change of sign here? No. So p of x has no change in sign. Okay. No change in sign in the coefficients. So this implies that p of x has no positive zeros. Then to find out the maximum number of negative zeros, let us find out p of minus x, which is nothing but minus x the whole cube plus 2 into minus x plus 3. That is minus x cube minus 2x plus 3. Here, how many sign change means? Only one, from minus to plus. So, number of sign changes in p of minus x is equal to 2. This implies that p of x has, the number of sign changes in p of x is only 1. So this implies that p of x has at most 1 negative zeros. Okay, 1 negative 0. And what is the degree of the polynomial? It is 3. So it has no positive 0 and 1 negative 0. That means that the other two zeros are imaginary. So this polynomial has 1 negative and 2 imaginary zeros. So that is nothing but option number 1. So what is the answer for the ninth one? Option number 1, 1 negative and 2 imaginary zeros. Last one, 10th one, the number of positive zeros of the polynomial sigma r is equal to 0 to n, ncr minus 1 the whole power r into x power r is dash, and the options are 0, n, less than n and r, right? See, what is the given polynomial? R is equal to 0 to n, ncr into minus 1 the whole power r into x power r. So what does this gives? This summation gives, when you substitute r as a 0, so nc 0 is 1, minus 1 the whole power 0 is also 1 and x power 0 is 1. So this is first one is 1. Then by substituting r as 1, nc1 minus 1 the whole power 1 means this factor decides the sign, either it is plus or minus. So when r is equal to 1, it will be minus, so minus nc1 into x. Okay. Then when r is equal to 2, this will be positive. So next term will be positive, then NC2 into x square. So in this way it goes on, and the last term will be minus 1 the whole power n. We don't know whether n is odd or even, so it will be minus 1 the whole power n into NCN, that is NCN is 1, which is x power n. Okay. So this is a polynomial. So what is its degree? Its degree is n. So it should have n zeros. Okay. And moreover, if you look at the sign changes from plus to minus and then minus to plus, plus to minus, so this will be minus, plus minus, there will be the number of sign changes will be n, because you know that as it has n terms, that is, this is nothing but expansion of 1 minus x the whole power n, and the power is n and it should have n plus 1 terms. So the sign changes will be n, right? So the number of sign changes is equal to n, because it will have n plus 1 terms, and therefore with the alternative minus plus, therefore the number of sign changes will be n. This implies that the maximum number of positive zeros is equal to n. Okay. Then let us check whether it has any negative. So let us take this to be some p of x, right? Then what would be p of minus x? So when you substitute x as minus x, this will become positive. So 1 plus NC1 into x. Then again this will be no change in sign in plus 2x square. Then third term will be x cube. So again this minus sign will become positive, NC3 into x cube, etc. And this one is also plus NCN is 1, that is simply x power n. Look at this, p of minus x, all the terms will become positive. That means that no change of sign. Okay. No change of sign in p of minus x. So this implies that p of x has no negative real zeros. Negative zeros. And then as it is of degree n, it should have n zeros and no negative zeros here. Therefore, all the n zeros must be positive, and therefore the number of positive zeros of the polynomial is exactly n. So which is nothing but option number 2, n.